Hello, my name is Doug Hubble. Welcome to Astrophotography Tutorials. Today is part 1 of the PoleMaster QHYCCD High Precision Polar Alignment Tool. Jeffrey Geiss is a special guest here, and he's going to cover today introduction, description of the problem, unboxing, and theory.
Hello everybody, my name is Jeffrey Geiss for Astrophotography Tutorials. As you probably know, every month Astrophotography Tutorials puts out a new video on the 1st and the 15th. Over there at the My Astro Images website, we've been talking about a new camera that's out. I ordered one, and Doug asked me to do a video. Hi Doug, I'm doing it finally. We're going to do a little unboxing. Last year I've been getting longer and longer exposures in my photography, trying to get narrowband imaging with HA filters 03 S2. And as many of you may or may not know, especially with me in these light polluted skies that I work in, you need to get fairly long sub exposures. So gone are the days of a 360-second exposure being good enough to get the signal to noise ratio that you're looking for. I'm shooting for 600, and I'd love to go up to 1200 seconds, which is 20 minutes. So the problem I'm getting now is that I'm getting field rotation. So if you don't know what that is, your stars are here, and as that thing's tracking, they're starting to spin in the image. And at 360 seconds, you don't see that little pinpoint movement, or that little arc. At 600 seconds, I'm just starting to see it. And at 1200, it's definitely a smear, and the stars make it the subs unusable. So what's the solution? It's polar alignment. Everything I've read, everything I've learned, everything people have told me is polar alignment is going to be your key to getting those long exposures. I've tried using the optical polar alignment scope that we're all used to bending down and looking at. Not fun, especially when the ground's a little moist, wet knees the rest of the night. Not hard, but not very accurate either. I've tried doing some of these standalone drift alignment programs with limited success. Recently, I've messed around with the PhD2 drift alignment features, gotten pretty close with it, but really at this point haven't gotten perfect polar alignment to get me those long subs I'm looking for. That being said, this new device that came on the market back in September, it just seems so logical to me that someone hadn't invented it before. It seems like a crime almost that it was that blaring that this may be the solution to my problems. The polar alignment issue is not a problem if you have lots of time. If you've got a permanently mounted pier in the backyard or in some other facility and you just have to roll your roof off and you've spent the hour or two to do your PA, your drift line, get it down right, get it perfect, and you can lock it and bolt it down and not worry about it. Great. Unfortunately for me and many others, we have to set up every night. Maybe we could set up and leave it out for a couple of days at the most if you're in the backyard. Generally one night and then everything's boxed up. That means that if we have to get those long subs, we have to do a drift align every night. And I'm not saying I'm good at it. It might take a lot less than this, but for me, spending an hour a night just doing a drift align after I've spent 45 minutes setting up all the equipment, as long as nothing else has gone wrong, that hour just to drift align is a painful hour to lose in a night that you might only get 8 hours of actual light time anyways. This device promises to change that if it does work. We'll find out, won't we? Digital camera that uses a software plate solving feature that will help align your various telescope. It works on many different brands and models in about 5 minutes, as the advertisement says, and it says it can get close to 30 arc seconds of accuracy. I went back while I was waiting for this, and I went back and looked at all my logs using PhD Lab, and my logs said that I couldn't get better than about 9 arc minutes of polar alignment accuracy. And if this thing can get me into that 30 seconds, I think that's a win. So here we go, standard foam packing peanuts in the foam plastic bubble wrap, labeled. Let's see what we got here. Nice tin can style case. Ziploc bag. All right. All right, what do we got here? This is the PoleMaster Electronic Polar Scope by QHYCCD. Oh, but let's go ahead and open up the box and see what we got. All right. A little quality control. Download instructions. Download your drivers. All right. So this is the adapter for my Atlas /EQ6 mount. Let's look at that first. Looks like it's a little two-piece. Is the portion that mounts inside of your gem, various models, and this is the part that's going to mount to the camera. There is a slight dovetail. That dovetail is going to allow that little tightening bracket to tighten down on that and give you a fairly tight fit. We'll find out how that works when it actually goes on the mount. All right, so what do we got here? Piece of foam. Oh, that's the camera itself. So the camera looks like it's attached through a little piece of foam. There it is. Very small device. Yep, like I suggested or suspected. There are 3 screw holes on the back of this, 3 screw holes in the back of that. That is most definitely going to mount up right there, and that will be the custom adapter for whatever mount you use. Looks like there is a standard micro USB plug here, and it looks like there's a couple of tightening screws, which might be interesting when we get to the cord. Nice little cap on the front with a little adapter or little tensioning screw so you don't drop that. I don't know. I've already lost, for those, I've already lost the cap from my Atlas. I've only had the thing 2 years. This little cap has threads here, small threads, and I like the way that fits. It's got a green stripe and then the QHY logos up on the front. It's made out of a, looks like it's out of a machined aluminum, and it's got like a powder coat. Doesn't feel like it's probably anodized. It's probably anodized. Now it's got a nice big lens on it. This is not one of those little micro pinhole lenses you see for your little cameras, your webcams. That is a fairly sizable lens. Inside there it says, and you can't see it, but I can. It says 3MP HD, 25 millimeter IR CCTV lens. So this is a closed circuit TV camera that's been retrofitted into this housing that will hopefully help us polar align. Let's look what else is in the box. Oh, wonderful. I was hoping it had one of these. I had just mentioned I lost the cap for my Atlas. Orion wants to sell me one for like 15 bucks. I put a piece of plastic I found in there that works, a little round thing. I don't have to do that no more. Now, when I mount my adapter, this cap with a nice QHY logo is now affixed to my Atlas. Nice. I like that. Now we just got to get a little cord for this cap. All right, what do we got in here? Here's your USB cable. As suspected, it has a what looks like a somewhat proprietary micro plug. Now, I tell you what, this is amazing, because how many of us have had these little micro camera plugs, these little USB plugs come off? This has little thumb screws that should keep that, look at that. They screw in real nice, and they should keep that from coming out in the middle of the night. Not that you're going to need your polar alignment scope after you set up, but this is an idea for those other manufacturers using these micros or any USB plugs. I know this is not standard equipment operating, but look at that. I like it. All right, and it looks like it's about that is a 6-foot cord right there. All right, so you got 6 foot of cord. And it's a fairly thick, somewhat pliable. I don't know how this will handle the cold. We'll find out. It is December, so we'll find out this weekend. The last thing in the box are, it's nice they sent the tools and then the screws that'll be used for putting your mount on. So how I understand this is supposed to work, you open up their proprietary software, and this has been mounted on your gem on its polar axis, and you're going to be roughly polar aligned. You're going to have Polaris somewhere in the field of view of this camera, which is supposed to be fairly easy because this is a fairly wide lens. You're going to take a shot with the software. It's going to grab a frame. You're going to select which star is Polaris. You're going to rotate the mount 90 degrees. You're going to take another shot with the software, and then you're going to select where Polaris is on that photo. Then the software starts to work, and it's supposed to calculate on that image the pixel that is in the center of that rotation. Hence, it will find on that photo where the polar axis is. And then I guess we'll find out. It's a simple act of having a refresh of the image, and you simply have some kind of, there's going to be some kind of crosshairs or some kind of a circle, and you're going to move that mount physically in both Alt and As to get that center pixel that the software has identified as the polar axis of that scope, the polar north, inside whatever target it has in the software. And then when it gets to that point, maybe it takes another shot, confirms it, maybe you rotate it back, take another shot, confirm it, maybe you do a couple iterations. They claim 5 minutes total time. I know with my mount it will probably be longer than that because those alt bolts, those altitude bolts on that Atlas are atrocious. I've not modified them. They are difficult to move that mount even when the mount is completely empty. One of the reasons why I don't like polar aligning that mount. Everything else I like about that mount. That being said, we'll see if this works. I've got high hopes for it, and I don't want to have to modify that mount to make polar alignment any easier. I'd rather use something like this and make it quicker. This is Jeffrey Geiss and Cosmo, the monochrome Coton, here. Thanking you for watching this, and we'll hopefully have the rest of this video ready for upload soon. We'll get the actual product demonstration and test and results done. So thanks again. Thanks for watching.
I want to extend a special thank you to Jeff today for showing us the unboxing of the QHYCCD camera. Stick around for part 2 coming up next. Also, if you have a astrophotography video you would like to share with everyone, please send it to me, dhubble@gmail.com, and I will work with you to help get that published here. If this is your first time watching, I'd like you to subscribe. I publish 2 astrophotography videos on the 1st and 15th of every month. Thanks for watching, and I hope to see you soon. Thanks to Jeffrey Geiss today for showing us the PoleMaster QHYCCD camera. Did I say that right? QHYCCD. Oh my God. Hope I didn't blow all the rest of the takes.